Hi, and welcome back to my channel. So this is a short video to talk about this little unit I just received. This is not about RF, but it is about components, electronic components testing. So my idea for buying this, by the way, I bought this for $15 delivered. And you can get it for a bit cheaper, but in my case the delivery was from China in just 1 week, so I decided to pay a couple of dollars more to get a fast deliver. As you can see, this unit is called the multifunction tester, TC1. And well, let me show what it is. Basically, it's a unit that allows you to check very quickly electronic components like resistors, capacitors, inductors, and transistors. I don't know if I already said that, diodes, and these type of things. So especially when you have a mess like this, a junk box of some sort, this is ideal for checking it out. Discovering what it is very quickly. For example, I'm really not good at, I'm not capable of decoding the value of a resistor from its colors. I don't know if you, so these colors that you have in resistors code up. You reading the colors, you can discover what resistance is. I don't know actually how to do that, so tool like that is kind of useful. Same thing with transistors. Those are even more difficult to check, and this unit does the job pretty well. So it comes in this electrostatic protection, and in the box you have some cables. I have not yet used them, but the idea is that you can connect the cables to the plugs here. As you can see, there are basically many ways to connect the components to this unit. So let me see if I can actually, okay, here it's reasonable. And they're basically, the ports are number 1, 2, 3, but as you can see there are several 1 points or 2 points, 3. These are all electrically connected, okay? So it doesn't matter on which 1 or 2 or 3 you put them. There are just several of them to be handy and to allow you for connect wherever is more convenient. And so accordingly you get these 3 cables to, if you want, not connect directly here, but with the cables to something that is a bit far away. So in the box you get these cables, you get these connectors. I'm going to tell you now what it is for. A LED diode and a small capacitor. So these are just 2 simple things to check that the unit works. So you charge this unit with just a USB cable, micro USB cable, like many other devices. It has an internal battery, and if you click start, the unit starts. As you can see here, it's trying to test what is connected here at the moment. There is nothing connected, so it says no, unknown, or damaged part. Okay, so the first thing that you want to do when you receive this unit is to calibrate it, or to make sure it's calibrated. In my case, even without the calibration, everything was working fine, the measurements were correct, but anyway, it's good to calibrate. So to do that, you take this connector, anyway, whatever piece of wire would do the job, you connect, you short basically the 1, 2, and 3 connectors, just like that. So as you can see, I'm basically shorting out 1, 2, and 3, and by this thing here you can make sure that they stay in place. I click on start, and as you can see, it detects that these things are shorted, so it starts self-test mode. It takes a very short amount of time, like 30 seconds. At some point, around 22%, it asks you to remove these connectors. So let me do that, and then it continues until it reaches 100%. So the unit will be calibrated and functioning properly at that point. So okay, and then we were going to check very quickly, just to exemplify how these things work, a few components that I have here. I don't know, let me see if I have something interesting. Yeah, here I have an inductor. Oh no, well, I should have some inductors around, so here I have some inductors. Let me try. Okay, so now it's calibrated. And okay, so let's just try to check something. Let me try with the LED first. So I connect it to whatever I want. So in this case, one leg to 1 and one leg to 2. So let me do that. Okay, well, actually it's more handy just to from 2 to from 2 to 3. Okay, it doesn't really matter. I fix them in position. I click start, and the unit just starts. As you can see, it sends some electricity test the unit, and it sees that it is indeed a diode, a LED diode, with a bias current of 1.82 volts, connected to pins 2 and 3. And it also gives you the direction, of course. Okay, if I start again, it reads more or less the same. This time it says 1.83 volts. So there is an accuracy, I think, of around 1%, which is good enough for this. It's interesting that it also tells you the capacitance of this unit in picofarads, 6 picofarads, as you can read here. So let me see if this is consistent. Yeah, it says that again. I don't know how accurate that is, but yeah, anyway, that's data that is produced when checking a diode. Let me see a capacitor, for example. So this time I'm connecting it from port 1 to port 3. Okay, so I'm starting again the test. And let's see what happens. And as you can see, I hope it says capacitor 10. So let me see if the camera can focus here. Yeah, capacitor 10.40 microfarads. Internal resistance of 0.94 ohm. Let's see again. Yeah, it's pretty accurate, as you can see, or at least the readings are you know, repeatable. And as you can see, when you do the measurement, it also tells you the level of the battery, so you can check if it really needs to be recharged using the USB port here. Okay, so yeah, this was a capacitor, and let me try with an inductor of 10 milliampere that I have in this box. Let's see if it works properly. So I'm connecting now in this other part of the connectors here, 1 and 2, pins 1 and 2. Okay, so let me run it again. Let's see what happens. Inductor, 10 millihenry. So that's exactly what I used. 10.2 it says. Interestingly, it also says R145 ohm. So I don't think this is, I have to read online what that means. I don't think the internal resistance can be so high for this inductor, but it might be, I don't know. I'll have to check about that. So let me see again. So yeah, the reading is actually consistent, as you can see. So let me see here. I actually have a LCR tester that performs similar operations. So out of curiosity, so let's see. I'm going to measure this inductor. So here it's not auto-ranging, unlike this device. So I have to set the proper position here on the knob. So let me see what happens. And so this is measuring 9.91 millihenry. Okay, so this should be 10. So this was actually closer. I don't know which one is more accurate. Of course, I mean, this device cost $15. As I said, this is more or less the same price. So both are definitely not high-end, very accurate instruments. Anyway, so let me see if it also measures something in terms of resistance. So yeah, here we're measuring 7.2 ohm. Interesting. The other was reporting 140 or something. Let me try with another inductor, just out of curiosity. Okay, so this is a let's see, this is a 1 millihenry. So okay, let's see, 1.08 and 47.2 ohm. All right, so let's see here what we read in terms of resistance. We read 3.2 ohms. Okay, so the readings of the resistance here is, I'm not sure if it is either completely wrong or there is a way to understand that number. I don't think the internal resistance can be that high, so I believe more this value here. And in fact, let me just check things with another, just a normal multimeter that I have here. Of course, you can check resistances. So one leg goes here and the other leg goes there. This one is measuring 9.6. All right, so every instrument that I have measures something different. Of course, these are all cheap instruments, okay? So, so far I didn't, really invest any money on a precision multimeter or precision LCR meter. I just don't need a precision on this setting, or at least for the moment. Basically, I don't have the money to invest on that. Anyway, my feeling is that the reading that I get from there in terms of internal resistance is too high. But we'll try to search online if there is an interpretation for that. Anyway, let me finally show what happens if I take a transistor, for example. I don't know, I just have a random one from there. I'm connecting, let me spread the legs slightly and see what happens. Okay, so I'm connecting again to pins 1, 2 and 3, of course. So let's see what happens. Yeah, and it finds out that it is a PNP bipolar transistor, and indeed yeah, that's the model 2N3906, which I know is indeed, well, let me actually check. I'm not sure it is supposed to be a PNP. Let me see if I can actually read the name here. 3906. Yes, it was that. So let me try again. Just out of okay, PNP. I thought it was an NPN transistor. Okay, good to know. Let me try with one that I know is an NPN, just to be sure that things are working properly. This is the popular 2N222, and so I put the resistor there. Let me plug this thing and test it again. Okay. Yeah, it's reading an NPN. Okay. Anyway, here you can see the beta factor and also, yeah, the bias voltage, the bias B voltage. And so, yeah, my conclusion is that I'm super happy about this device. You know, sometimes these very cheap things are worth buying, I think. It allows very quickly, if you have a junk box like this, to see what you have. For transistor, diodes, LEDs, resistors, inductors, and yeah, it works pretty well. For the inductors, in fact, the limit stated in the data sheet, I mean, in the description of the product online, is of 10 microhenry. So let me see if it can measure. This is a 10 microhenry inductor. Let me see if it can discover that. Inductor, yeah, exactly, 10 microhenry, precisely. And here it says the internal resistance is 0.3 ohm. Yeah, let me actually see if we get the same reading here. 0.5. So yeah, I have the impression that for high inductors, the reading of the resistance is not accurate, but for low ones, this time the two things agreed. Anyway, that's just a rough measurement. So the point of this is, of course, not to don't buy this if you expect a precision instrument. It's just something for the hobbyist. For just a few dollars, you have something that can check your junk box components very quickly with a nice graphical interface. Oh yes, there is another feature that is pretty interesting. I mean, I don't know if it is so useful, but there is also an infrared reader here. And so here I have the the remote control of my television. And so let me turn on the device, and I don't know, I push, let's see, I'm here, I don't know if you can see, yeah, let me push the number 5, and it's decoding what that is, okay? So it's the code that is remote sense. Let me now push number 6, and it's a different number. If I push 6 again, stays the same. I'm now pushing 9, and that's yet another number, okay? So that's pretty cool as well, I think. Yeah, so I think it doesn't work for all kinds of remotes, but many of the remotes use the same type of coding for data. It's kind of standard, and for those remotes this thing can be useful for testing, for understanding what's going on if you're playing around with some infrared remote controller. Anyway, that's all for this video, and yeah, if you have any comments about this unit, feel free to leave a comment in the section below. Bye bye.